The ancient Egyptian calendar was a solar calendar having a fixed 365 days per year. Now the Earth revolves around the Sun at almost exactly 365.256,363,004 days, and unlike other calendars that have leap years, wherein the discrepancy is corrected every certain period of time, the Egyptian calendar does not compensate for the 0.256,363,004 of a day difference every year. This means the Egyptian New Year is observed one day earlier or slides back one day every approximately 4 years. The Sothic cycle is a period of about 1,461 Egyptian calendar years of exactly 365 days each, which is equivalent to about 1,460 solar years, averaging 365.25 days each. At the end of one complete Sothic cycle, the calendar, having 365 days a year, loses enough time that the start of its year or its new year once again coincides with the heliacal rising of Sopdet, Egyptian name, or Sothis, Greek and Latin name, which Egyptologists associate with the star Sirius. I said the Sothic cycle is about 1,460 solar years because the start of a new Sothic cycle depends on actual observation of the star rise of Sopdet falling on the day before the Egyptian New Year's Day, and the precession of Earth's equinoxes causes the date of the heliacal rise of stars to move forward slowly in time. For example, the star rise of Sirius was June 18 Gregorian calendar in 3500 BC, but was June 30 Gregorian calendar in 2000 BC, or an advance of 12 days in a period of only 1,500 years, which, by the way, is just 40 years more than the supposed 1,460 years Sothic cycle. Because of this, the actual observed period of the Sothic cycle should be less than the calculated and presumed 1,460 solar years. The Egyptians call the start of a new Sothic cycle a great or divine year, and it corresponds to the life cycle of the sacred phoenix or the Bennu of Heliopolis, which is a symbol of rebirth. Now the first month of the Egyptian calendar is Thoth, which is by name only the first month of the flooding season, which the Egyptians call Akhet. I said by name only because this becomes true solely at the start of the Sothic cycle, when the first day of the first month of Thoth starts on the heliacal rise of Sopdet. Most scholars agree that the Egyptian day began at dawn before the rising of the sun rather than sunrise, and the heliacal rise of Sopdet is cited during this time. Thus, the Sothic rise falling on the first day of Thoth marks both the end of the previous Sothic cycle and the start of a new one. The concept of a Sothic year comes to us via a Roman author named Censorinus. In 238 AD, he wrote that 99 years before, or in 139 AD, a great year began on the Egyptian calendar, which is based on the motions of Sirius, the dog star, and that it is 1,460 years long. Astronomical calculation definitely dates this heliacal rising to July 20, 139 AD Julian calendar. Theon of Alexandria, who lived a century after Censorinus, agreed with him and declared that the previous Sothic cycle began with the era of Menophress in 1322 to 1321 BC, or exactly 1,460 years before July 20, 139 AD. Armed with that information, the Egyptologists looked for a pharaoh named Menophress. They settled on Ramesses I because one of his other names was Menpetire. Since Ramses is credited with only a one-year reign, both he and the beginning of the 19th dynasty were initially pegged at 1321 BC, although it has now been revised to 1292 BC. The earliest record of the start of the Sothic cycle can be found in the ivory tablet of Jer, the third pharaoh of the first dynasty of ancient Egypt, whose capital was in Thinis. This heliacal rise was dated by Egyptologists on July 17, 2773 BC Julian calendar. However, this date is too late for Jer's reign, which is dated circa 3000 BC. And this is a big problem because the Sothic cycle was used for absolute dating of the Egyptian chronology, not just for the 19th dynasty under Ramses I, which I discussed earlier, but also for the 18th dynasty and the 12th dynasty. And if the Sothic rise calculation for Jer's reign is too late, then this means the Sothic rise calculation used for dating the other dynasties may be faulty as well. In my previous video titled Sothis is Aldebaran, the eye of Ra, and the red Sirius is Ayin, the eye of Horus, the two eyes of Taurus, I discussed in detail the imagery found in the ivory tablet of Jer as follows. Thus, in summary, the ivory tablet of Jer is telling us that the heliacal rise of Sopdet Isis, or Aldebaran, the sun disk of Ra between two horns, whose star rise signals the start of the flooding season, happened in the constellation Taurus, the stooping bull representing Apis, the son of Hathor, while Venus, the feather of Ma'at Isis, representing Horus, was between the two horns of Taurus on the day a new Sothic cycle started. The actual location of Thinis, the capital of the first dynasty pharaoh Jer, remains undiscovered, so I will be using the coordinates of the center of a total solar eclipse located in Egypt instead. This eclipse, I believe, occurred sometime during Jer's reign. Using stellarium and setting the algorithm of delta T to Chaperon 2s and Chaperon 1991, the location at coordinates 27 degrees 31 minutes 57 seconds north, 33 degrees 10 minutes 59 seconds east, the date to May 15, 2817 BC or negative 2816 in astronomical year numbering, and at 2:16 UTC, one can see the heliacal rise of Aldebaran. Setting the time at 2:34 UTC, one can see Venus rising from the horizon. According to Stellarium, its heliacal rise should have happened on May 21 still, or 6 days later. However, looking at Venus' visual magnitude at that time, it was already at 0.73 or below magnitude 1, which is the limit for naked eye visibility during a total solar eclipse and is similar to the day sky during early dawn. So it may be possible that May 15 was also the heliacal rise of Venus coinciding with Aldebaran, a not so common coincidence. Note also that the ivory tablet of Jer placed the Ma'at feather representing Venus below that of the son of Ra representing Sopdet or Aldebaran. This implies that the visible rising of Venus above the horizon followed that of Aldebaran, which was actually the case on May 15, 2817 BC. Setting the time at 15:33 UTC, one can see a total solar eclipse just 30 minutes before sunset, allowing Mercury to be visible during daytime. The center of the eclipse was and still is part of Egypt, and I believe this is the true location of Themis. Note also that this eclipse was positioned at the left side of the club of Orion, while Orion and his club was positioned at the left side of Taurus. Now look again at the ivory tablet of Gier. There, one will see a club at the left side of Taurus, or the stooping cow. Furthermore, at the bottom left side of the club, one will see a circle with an inclined cross inside. The club at the left side of the stooping cow in the ivory tablet is, of course, the club of Orion, while the circled cross symbol at the bottom left side of the club represents the solar eclipse which happened at the left side of Orion's club. This circled cross is below the Sun of Ra and the Ma'at feather, implying that the eclipse happened after the heliacal rise of both Aldebaran and Venus on that same day, and which actually was the case. Now note the arm and hand pointing at the club in the ivory tablet. This arm is the right arm of Auriga, which is also pointing at Orion's club in the sky. Auriga is often portrayed as a charioteer, and the square with 9 smaller squares inside represents his chariot on top of the circled cross, the eclipsed sun serving as its wheel. The chariot on top of a circled cross wheel is a very ancient symbolism. The 9 smaller squares inside the square chariot represents the 9 deities of the Ennead, namely Shu, Tefnut, Geb, Nut, Osiris, Isis, Set, Nephthys, and Horus the Elder, while the sun god Atum is represented by the circled cross. Now notice the falcon sitting on top of the 2 boxes joined or stacked together. The 2 conjoined boxes represent the conjoined twins Castor and Pollux of Gemini, and the falcon sitting on top of the boxes, or the foreground of Gemini, represents the falcon god Horus, who was represented by Mercury that day, and which momentarily appeared in Gemini during the time of the eclipse. Apparently, Horus is represented not just by Venus, but also by Mercury as well, which are the 2 planets closer to the Sun than Earth. I believe May 15, 2817 BC is the correct date of the earliest recorded heliacal rise of Sopdet, and was the Egyptian calendar's first ever New Year's Day. Note, however, that May 15, 2817 BC is about 44 years earlier than the July 17, 2773 BC date calculated for the star rise of Sopdet during Gier's reign based on Censorinus' account. And this is understandable. After all, almost 3,000 years have passed between the first recorded Sothic cycle and the time of Censorinus. Because the precession of the equinoxes advances the date of the heliacal rise of stars slowly over a period of time, the Egyptians cannot use a fixed period of 1,460 solar years to mark the end of a Sothic cycle. So the Egyptians must use another celestial sign to mark its end, and this marker should coincide with the star rise of Sopdet for the effect of the precession on both the celestial marker and the star rise of Sopdet to match. The celestial sign that coincided with the star rise of Sopdet in May 15, 2817 BC was the solar eclipse. And a solar eclipse coinciding with the heliacal rise of Sopdet can be calculated or predicted because it occurs regularly over a fixed period of time. The orbit of the moon is inclined with respect to the orbit of the sun, and a lunar node is either of the 2 orbital nodes of the moon, that is, the 2 opposite points at which the orbit of the moon intersects the orbit of the sun. A lunar eclipse can occur only when the full moon is near either lunar node within 11 degrees 38 minutes ecliptic longitude, while a solar eclipse can occur only when the new moon is near either lunar node within 17 degrees 25 minutes. Now notice the eye of Ra, a symbol of Sopdet, represented by the red solar disk. Below it, one can see a two-headed cobra named Wadjet looking at opposite sides of each other. I believe this two-headed cobra represents the two opposite orbital nodes of the moon, responsible for solar and lunar eclipses. In Hindu astrology, the two opposite lunar nodes are named Rahu and Ketu, and they are both represented as a snake. Because the moon has two lunar nodes located opposite each other, and because the synodic orbital period of the moon is about 29.530589 days, two successive eclipses, one lunar and one solar, happens consecutively and separated by about 14.7652945 days from each other, or half the synodic orbital period of the moon. So for the ancient Egyptian astronomers, a solar eclipse visible in Egypt on the same day as the star rise of Sopdet, or a lunar eclipse visible in Egypt about 15 days earlier, should be the celestial marker they are looking for to declare the end of the current Sothic cycle and declare the beginning of a new one. A lunar eclipse visible in Egypt using the same coordinates which I used for Jer's Sothic rise observation was observed on May 8, 1385 BC at 21 UTC, or about 15 days before the heliacal rise of Sopdet on May 23 at 2 UTC of that same year. And this is why the Egyptian astronomers declared May 23, 1385 BC as the end of their current Sothic cycle and the start of a new one. This new Sothic cycle started during Menophthes' reign, according to Theon of Alexandria. I discussed this topic in detail in my previous video titled May 15, 2817 BC was the start of a 523,046 days Sothic cycle, and the Sothic rise during Menophthes' era was on May 23, 1385 BC. Now recorded dates of the star rise of Sopdet with their corresponding Egyptian day, month, and season, as well as the regnal year of the pharaoh at the time of the heliacal rise, were discovered, and Egyptologists use these to have absolute dating of those observations and therefore the dates of the regnal years of their corresponding pharaohs as well. The Elephantine Stele, presumed to be produced under Thutmose III, gives us a date for the heliacal rise of Sopdet, although it did not provide the regnal year of the pharaoh or even the name of the pharaoh. The Sothic Star Theory of the Egyptian Calendar by Damien Mackey, page 119. The Elephantine Stele inscription was the second of two New Kingdom texts recording a rising of Sirius. The stele presumed to have been produced under Thutmose III, though it does not actually state the name of the king nor provide the year of his reign, is interpreted as recording that the Sothic rising took place on the 28th day of Epiphi. The heliacal rise of Sopdet happens once every year, and yet only a handful of documents that recorded the heliacal rise of Sopdet with their corresponding dates and the regnal year of the pharaohs were found. The reason, I believe, is that the Egyptian astronomers only record the dates of Sopdet's heliacal rises whenever an eclipse, both lunar and solar, was observed in Egypt, either during the 5 epagomenal days or about 15 days before any of the 5 epagomenal days. The 5 epagomenal days are also known as the 13th and last month in the Egyptian calendar, and the heliacal rise of Sopdet happens on the 5th day. Also, the birthdays of 5 deities were celebrated during the 13th month, namely that of Osiris, Horus the Elder, Set, Nephthys, and Isis, and I ordered their names according to the order of their birthdays as observed during the Ptolemaic and Roman period. Now remember, two successive eclipses, one lunar and one solar, happen whenever the new moon or full moon are near the two opposite lunar nodes, which are separated by about 15 days of motion by the moon around the earth. And these two successive eclipses, occurring either during the 5 epagomenal days or about 15 days before any of the 5 epagomenal days, are caused by the two opposite lunar nodes in the same or almost the same position in the sky that marks the end of a Sothic cycle. The period of the intercalary month was considered spiritually dangerous, and the pharaoh performed a ritual known as pacifying Sekhmet to protect himself and the world from that god's plague. Apep was the ancient Egyptian deity who embodied darkness and disorder, and was thus the opponent of the sun god Ra and Isis Ma'at, representing order and truth. Apep was seen as a giant serpent, leading to such titles as Serpent from the Nile and Evil Dragon. According to his myth, Apep is responsible for eclipses. The 5 epagomenal days are already spiritually dangerous by themselves, but combining any of these days by an eclipse during or about 15 days earlier make these days especially ominous. This is why the pharaoh has to make a declaration that in spite of the eclipse, Isis Ma'at, represented by Sopdet, succeeded in its heliacal rise on the 5th day. One such eclipse, a total solar eclipse, had its center with coordinates 24 degrees, 46 minutes, 42 seconds north, 33 degrees, 57 minutes, 59 seconds east. These coordinates are very near that of Thebes, which was the capital of the 18th dynasty, during which the Elephantine Stele is believed to have been built by an unnamed pharaoh. The eclipse occurred on May 18, 1124 BC, or negative 1123 in astronomical year numbering, at 7:54:53 UTC. You can verify this using Stellarium and by setting the algorithm of delta T to JPL horizons. The heliacal rise of Aldebaran, which I believe to be Sopdet, was on May 23, 1124 BC at 1:59 UTC and as observed at the center of the total solar eclipse. Note that this solar eclipse on May 18, 1124 BC is not the same as the solar eclipse occurring on the same day as the heliacal rise of Sopdet, which marks the end of a Sothic cycle. Nevertheless, this eclipse happened 5 days earlier, or on the first day of the 5 epagomenal days, marking the birthday of Osiris, and it was an important omen to the ancient Egyptians and thus deserved to be recorded. Now, what is the corresponding Egyptian date of the May 23, 1124 BC heliacal rise of Sopdet as observed in the center of the total solar eclipse? The most recent heliacal rise of Sopdet, falling on the start of a Sothic cycle before the Sopdet rise on May 23, 1124 BC, was on May 23, 1385 BC, which I already mentioned earlier. The number of days between May 23, 1385 BC and May 23, 1124 BC are 95,330 days. Dividing 95,330 days by 365 days gives the number of Egyptian calendar cycles between these dates, which is about 261.178,08219 cycles. Each cycle of the 365 days Egyptian calendar is 0.256363,004 of a day shorter than the actual length of the solar year, which is about 365.256,363,004 days. multiplying 261.178,082.19 cycles by the 0.256,363,004 of a day discrepancy per cycle gives about 66.956,3977 days, or 67 whole days, which the calendar date of the Sopdet rise slid backwards from the 365th day of the Egyptian calendar. This means the heliacal rise of Sopdet that happened on May 23, 1124 BC was the 298th day of the Egyptian calendar. Now each Egyptian month has exactly 30 days each. So this means the heliacal rise of Sopdet that happened on May 23, 1124 BC was the 28th day of the 10th month of Pini. However, the Elephantine Stele supposedly said the Sopdet rise occurred on the 28th day of the 11th month of Epiphi and not the 28th day of the 10th month of Pini, or did it? The Elephantine Stele is believed to have been built by an unnamed 18th dynasty pharaoh who came after Amenhotep I. Some Egyptologists actually believe the unnamed pharaoh was Thutmose III, who was the fourth pharaoh who came after Amenhotep I. The heliacal rise of Sopdet during the reign of Amenhotep I was dated by the Ebers papyrus on the 9th day of the 11th month of Epiphi. Now because the Egyptian calendar is only 365 days long, as opposed to the almost 365.256,363,004 days length of one solar year, a day in the Egyptian calendar is observed one solar day earlier or slides back one solar day every approximately 4 years. And since the reign of the unnamed pharaoh of the Elephantine Stele came after the reign of Amenhotep I, the date of the Sopdet rise in the Elephantine Stele should be earlier, not later, than the date of the Sopdet rise in the Ebers papyrus. But the Elephantine Stele supposedly dated the Sopdet rise on the 28th day of the 11th month of Epiphi, which is later and not earlier than the 9th day of the 11th month of Epiphi for the Sopdet rise in the Ebers papyrus. For this reason, I believe the Elephantine Stele either had an error in writing the date of the Sopdet rise by Egyptian astronomers or had an error in reading the date of the Sopdet rise by Egyptologists. Now, if one looks at how the 11th month of Epiphi was written in the Ebers papyrus, one can see that it was written as the 3rd month of the season of harvest, named Shemu. The 10th month of Pini is the 2nd month of the season of Shemu, and the only difference in writing between the 2 months is just one stroke of a vertical line. So it was easy for a mistake either in writing or in reading to happen in this case. So who was the unnamed pharaoh of the Elephantine Stele? In my previous video titled May 15, 2817 BC start of a 523,046 days Sothic cycle and the Sothic rise of the Ebers papyrus was on May 22, 1170 BC, I dated the Sopdet rise in the 9th year of Amenhotep I to May 22, 1170 BC. Since the Sopdet rise of the Elephantine Stele was on May 23, 1124 BC, this means the Sopdet rise of the unnamed pharaoh came 46 years after the 9th year of Amenhotep I. Using the current Egyptian chronology as my reference, this unnamed pharaoh or pharaohs should be both Hatshepsut and Thutmose III of the 18th dynasty, with the Sopdet rise occurring in their 10th year. This is assuming that Amenhotep I ruled for 21 full years, which Egyptian chronology credits him. However, Amenhotep I's highest attested regnal year is only his year 10, and if this year 10 is only partial and really short, then Amenhotep I may have reigned only for 9 full years. This means also that the Sopdet rise recorded in his 9th year marked the end of his 9 years' reign. I believe Amenhotep I may have abdicated his throne in his 9th year to his successor Thutmose I, and although a passage in the tomb autobiography of a magician named Amenemhet explicitly states that he served under Amenhotep I for 21 years, it may have included 12 years of Amenhotep I's retirement. If we are to deduct 12 years from the 21 years which Egyptian chronology credits Amenhotep I, this means the Sopdet rise recorded in the Elephantine Stele occurred in the 22nd year, not the 10th of both Hatshepsut and Thutmose III. Now, the 22nd year of Hatshepsut was also her last regnal year, and the precise date of the beginning of Thutmose III's reign as sole ruler of Egypt and presumably of Hatshepsut's death is considered to be year 22, second month of the season of Peret, day 10, as recorded on a single stele erected at Armant. The second month of the season of Peret is also the 6th month of the Egyptian calendar of Mechir, which means Hatshepsut must have already died at the time of the Sopdet rise on the 28th day of the 10th month of Pini. Thus, the unnamed pharaoh of the Elephantine Stele was Thutmose III. Hatshepsut is known to have celebrated a said festival in her 16th year, although said festivals are supposed to be celebrated after a ruler had held the throne for 30 years. Egyptologists defended this anomaly by saying that Hatshepsut was counting the time she was the strong consort of her weak husband, Thutmose II. However, I believe a better explanation would be that a total solar eclipse was observed at the latter part of her 16th year. Since I dated Hatshepsut's 22nd year in 1124 BC, this means her first year was in 1145 BC, and the latter part of her 16th year would be in 1129 BC. This total solar eclipse occurred on February 14, 1129 BC, or negative 1128 in astronomical year numbering at 746 UTC. The center of the eclipse was 29 degrees, 20 minutes, 48 seconds north, 30 degrees, 30 minutes, 4 seconds east, which is currently the city of Fayum, located 100 kilometers southwest of Cairo. You can verify this using Stellarium and setting the algorithm of delta T to JPL horizons. Current Egyptian chronology dated the 22nd and final year of Hatshepsut to 1458 BC, while I dated it to 1124 BC instead. This means Egyptian chronology of the 18th dynasty, at the very minimum, is 334 years too early. In one of my next videos, I will discuss how to correct this error.